In this video, we're going to look at the servo and pins and ways to use them, for example, to make a gate. So the servo consists of the arm, or usually called the horn in RC language, the body, and the assembly. When I open the assembly, you can see I've added these red pins. These are placeholders so that when you use mold cavity, the space in the wood will be cut out for a screw. So you can mount the servo and you can mount something to the arm. This center one is a 1/8 inch diameter. That's to match a pin potentially on the other side. The servo arm itself is rotatable, of course, to any position you want. And so if you prefer to have it start in that position, you can do that. For some ways of designing, it's helpful to have the servo arm square to one of the planes, and so if you're doing that, then you don't want to save it in one of these configurations. Just hit undo until it's back to the default. And here I have the servo attached in a sample assembly just to show how a gate might work. So the servo is on one side, a pin is on the other side. That's an 1/8 inch pin, and those are on the same axis so that the gate can rotate. The servo is mounted to a block you can see here. This block is actually 3 layers of the 1/8 inch plywood, or the 0.11 plywood. So this particular block is 0.33 thick, and that way you can easily make it out of laser cutting. If you use that 0.3 thickness, you'll be able to put the servo arm, you can kind of see it there, just inside of the inside surface, which is often helpful. And that is mounted to a side plate for the gate, which you can see is finger jointed to the gate itself. The idea of the mounting would be that one screw would go there, one screw would go there. That would lock this side plate to the arm. I lost it, so I'm going to hit zoom to fit to get back into place. This pin would actually not be used because it's just a placeholder. Its main purpose is so that we can line ourselves up with that pin there. And if we do a cutout on the left side, it will be the same diameter cutout as the right side. So this is one option for how to do a gate. You can make this gate swivel. However, when you put a assembly into another assembly, it locks that any rotations. So if we want to unlock that, it's very simple. You right-click on the assembly that you want to unlock, right-click there, and then go to Make Subassembly Flexible. Click that, left-click. And now the way I've got this set up, I can take my gate and rotate it up. And then you can check this way that the steel bar will indeed be able to roll out and not be hit by the gate or any part of it. And to put the gate back down, I'm going to hit Control-Z to put it back to the default position. This is certainly not the only way for a servo to actuate a gate. As you can imagine, another straightforward option, at least for SolidWorks, would be to mount the servo on the other side. So you have dual servos controlling the gate. The advantage there in SolidWorks is its complete symmetry, but the disadvantage is, if you think about it, this servo, when it opens the gate, would have to have its arm rotate counterclockwise, whereas the servo on this side, if it's oriented in a mirror image, that servo would be rotating clockwise. And so you would have to have different electrical signals sent to each servo to accomplish that. Certainly can be done, but it would require a little more coding and probably at least one more wire. And here's a third way that you could have the servo actuate a gate. In this case, the gate is almost entirely symmetric on the left and right sides. We have an 1/8 inch pin there on the left side, and we also have an 1/8 inch pin here on the right side. Those are collinear, so that the gate can swing. It's almost the same plate on the left and right side, just with a small extension you can see on this one, but you could make them symmetric. And we're actuating the gate by a little mechanism. The servo is behind it, the arm is here, and this is a link that will pull up. And for this mechanism to work, you can see if I take the arm, we want the gate to open 90 degrees. And so to keep things reasonably simple, I want the servo arm to rotate also 90 degrees. The best way for it to do that is to start about 45 degrees leaning forward and then to end about 45 degrees leaning back. And similarly, the gate is, if you look at the angle between the pivot and its actuation pin there, that's starting about 45 forward, and then in the final position, fully open, that's about 45 degrees back. Those angles are good because you can see the servo is going to be most effective. It's going to have the most direct actuation when the arm is 90 degrees to the link direction. And so that gives it the best motion when it's close to 90. Weird things happen when mechanisms go beyond 90. You can see at this point the servo arm is rotating, but the gate is hardly moving at all. And that's because that's called a toggle position. So we want to generally avoid those. And there's another toggle position here. You can see some wacky things happen as the mechanism tries to accommodate those motions. So in general, try to keep the angles between the arms and the links to be not 180 degrees and not 0 degrees. Keep them 90 plus or minus 60 degrees or so. I'm not saying that this mechanism is better. It's of course a little nifty to have it, but it's, I would say, more complex than the other one. I want to emphasize that these are just examples of how a gate could be actuated, assuming you have a gate. You might have some other feature or use for the servo to release the bars. For example, you might have a floor that is actuated by a servo to lift the floor, to tip them out. It's important that you follow your own design for your team, but I am going to show a few of these designs so you can see the methods involved of using servos and pins and having motion and gates. Now I'll make two more screencasts. The first one will cover the first design that I showed where the servo is directly actuating this side member, and the second one will cover this one. They won't go into nitty-gritty detail of how to size things, but I'll show you how to assemble things so that you get motion and how to simplify your work with mirroring.